Dear students, today is the second class of integral calculus. In the first class we discussed as a recapitulation of some basic formulae of integral calculus along with few examples. In continuation with that, few more examples need to be discussed. Let's take another example today. This one, integration x to the power 4 minus cube root of x divided by 6 root over x dx. So this, which is a fractional form, the function is in fractional form. So it looks a little bit difficult to integrate, but actually if we split it, again it would be possible to express to integrate using the x to the power n formula. So if we split this divided by this minus this divided by this, then this fraction will be splitted into two fractions, and ultimately it will be expressed in x to the power n form. And next step we will be having this one, x to the power 4 by this is this one, this divided by this will be having this one, these two fractions, and this fraction x to the power 4 divided by 6 x to the power half, it can be simplified, x to the power 7 by 2. So now it is integrable easily using x to the power n formula. And similarly here in the second fraction, 1 by 6 x to the power minus 1 by 6 dx. So now these two fractions, these two functions, we can integrate individually. Integration of this minus integration of this, and doing this through x to the power n formula, x to the power n plus 1 divided by n plus 1 formula. If we apply this here directly, we will be having this one, 1 by 27 x to the power 9 by 2 minus 1 by 5 x to the power 5 by 6 plus integration constant c. So this is the result of the integration of the functions. It's very simple, just we need to split into two fractions, and then it will be turned to x to the power n form, and so that we can go through the formula x to the power n. Next, consider another example, very simple trigonometric function. Integration sin x plus 10 cosec x square x dx. So it's very simple. Integration of the first plus integration of the second. Integration of the first, that is integration of sin x. You know from the formula directly you can write minus cos x, and 10 cosec square x. 10 is constant as it is, and integration of cosec square x by the list of the formula you can write directly. This is cot x. So minus cos x minus 10 cot x, and plus of course integration constant. Similarly, in another example here, integration 2 cos w minus sec w 10 of w dw, that is the variable is w, and with respect to w we need to integrate here. So very simple, integration of the first function minus integration of the second function. Integration of the first, that is 2 cos x, you can treat it 2 cos x. So integration of cos x, you know by the formula sin x. So it is w, so cos w, it will be definitely sin w. Constant 2, it remains as it is, minus sec x tan x form. So integration of sec x tan x, this is another formula. Integration of sec x tan x is sec x. So integration of the second part would be sec w, and of course integration constant c. So this is a very simple integration, basic trigonometric functions. So the students look at another example, integration 12 plus cos theta. Now variable is theta, cos theta whole into sin theta plus cosec theta d theta. With respect to theta we need to integrate. So initially directly it is not integrable, so we have to simplify a little bit. uh, so it is plus sin theta and cos theta is here. So if we multiply by this, that is open of the bracket, then you will have in its expansion form like this. Just multiply cos theta into sin theta, cos theta into cosec theta, and cosec theta into cosec theta, cosec square theta. So if we multiply this, and three terms will be having, first, second, third, three terms are there. Now it is cos theta, cosec theta, sin theta. Cosec theta is 1 by sin theta, you know. So it is giving us 1. So this 1 plus this 12, 13. This becomes 13. Now cosec square theta, it remains as it is. So this is just simplification before integration. Now integration of this, that is integration of 13, integration of cosec square theta d theta. So integration of 13, it's constant as it is. So integration of d theta simply comes here, and integration of d theta is theta, plus integration of cosec square theta. So you know, integration of cosec square x is the formula. So integration of cosec square formula is minus cot. So ultimately result of this integration will be having this 13 theta, and integration of cosec square is minus cot theta. So plus integration constant c. So this is the result of the integration of this example. So dear students, let's go to another example. This one, t to the power 3 minus e to the power minus t minus 4 divided by e to the power minus t dt. So in this fraction, first one, integration of t cube dt, it's no problem, x to the power n formula. Obviously t to the power 4 divided by 4, it will be the result of its integration. Now integration for the second term is this one in fractional form. It is not ready to use the formula here directly, so definitely we have to split it up. So let's back up this one. So this divided by this minus this divided by this. So thus we get two fractions, and these are this. Now e to the power minus t, e to the power minus t, obviously it will be cancelled out, which gives us 1. So t cube minus 1, so this is t cube minus 1. And 4 constant as it is, so e to the power minus t. If we write in the numerator, then we will be having e to the power t, so e to the power t dt. So just we got the expression of the function in this form after simplification. Now we need to integrate. It's a polynomial form, so very simple. Integration of the first t cube, that is t to the power 4 divided by 4, obviously this one, t to the power 4 by 4, minus 1, integration of 1, you know, t. If it is x, then it would be x definitely, so it is t, so therefore integration of dt is t, so t here, plus 4 constant as it is, e to the power x differentiation, integration e to the power x remains as it is, so integration of e to the power t remains as it is, e to the power t, and plus integration constant c. So next another example, formula based example. So integration of 1 by 1 plus x square plus 12 by root over 1 minus x square dx. So integration of 1 by 1 plus x square, it's a standard form, that is formula, that is integration of this, you know, it's tan inverse x. And again integration of 1 by root over 1 minus x square, it is formula for sin inverse x, 12 constant, so it remains as it is, so 12 remains as it is. So integration of 1 by root over 1 minus x square, it's a straight formula for sin inverse x, so integration of this sin inverse x, so the result is tan inverse x plus 12 into sin inverse x. So direct example based on the formula. And next similar example is this one, 6 cos z, now variable is z, plus 4 divided by root over 1 minus z square dz. So integration of the first plus integration of the second, integration of the first 6 constant as it is, integration of cos z, it is sin z by formula, plus integration of this 4 constant, so 4 remains as it is, so integration of 1 by root over 1 minus z square. This is specially straight formula for sine inverse x. Here z, so it is sine inverse z. So this is the result, 6 sine z plus 4 sine inverse z plus c. Now look at another example. It's a little bit different. Determine fx given that f dash x is equal to 12 x square minus 4x and f of minus 3 equal to 17. This additional condition is given. So first of all, derivative of a function is given. When derivative of a function is given, and if we integrate that result, so definitely we can get back the function, original function, because that is integration is the antiderivatives. So when we integrate any function, then we get a function, original function, actually whose derivative is the integrand. So if we integrate this one, this is integrand, and the result of this integration will be original fx, not f dash x, original fx. But the problem is, if we integrate this one, we get back the function, no doubt, but the result will consist in integration constant. So that constant compulsorily we used to associate, which is compulsory in indefinite integral, and that constant we have to evaluate here in this case with the help of this condition. F of minus 3 is equal to 17. So using this condition, we can find the value of the involved constant, integration constant c. So first of all, we have to integrate this function. We will be having the function involving integration constant c. So if we integrate the function, then we have this one, integration of 12x square minus 4x dx is equal to 4x cube minus twice x square plus integration constant c. So this is the result of the integration of this function. So this is actually fx. We need to find this one. Just here c is associated. We have to remove this c, and for which one condition is given, that is f of minus 3 is equal to 17. So f of minus 3 is 17, then fx is this one. That means if x is this, x is replaced by minus 3, then we get 17. This is the logic. If fx is this one and f of minus 3 is 17, then x is replaced by minus 3, then we definitely get how much? 17. So using this condition, so we can apply directly here. Minus 3 we can put here directly, and this will give us the value, this one, minus 1 to 26 plus c, when we put minus 3 here. And if we put minus 3 here, definitely f of minus 3, and which is already given 17. So in place of this we can write 17 here, 17, and when we put x equal to minus 3 here, we get this result. So this is a simple linear equation. This gives us c is equal to 143. So if c is equal to 143, that is integration constant, specifically we found out that is 143, and in the result of integration, was in this case 4x cube minus twice x square plus c. So in this result, just we have to replace this c by this value, and then we get the original function, and then we get the original function is fx is equal to 4x cube minus twice x square plus 143. So this is the original function, and if this original function is fx is this one, and definitely in this function, if we differentiate, then we can get this one. That is, if we differentiate that original function, we will get again this result. So it's hold because of integration is considered as the antiderivatives. So These types of examples will make you more clear uh, perspective, enter the fundamental perspective of uh, integral calculus. That is integration, why integration is treated as the antiderivatives.